Hi everyone, in this video I'm going to talk about normalization in database tables. So let's start with what's normalization. Normalization is a process, it's a database design technique, and it's a process for organizing tables in a way that you get rid of redundancy and dependency of the data. And normalized tables have the minimum number of attributes necessary. You don't have more than the amount of attributes you need. Okay, so you break it down to minimum number of attributes. And attributes are usually closely related in a logical sense. They are put in the same tables. So you're trying to get a more cohesive relationships this way. And normalized tables have also minimal redundancy. We're not repeating the data. This is one of the primary goals of normalization process. And this means that each attribute is represented once, with an exception, which is the foreign keys to connect tables to each other. Now, why do we do normalization? To reduce redundancy and data dependency, using minimal storage. You have less data, you need less storage, less expensive. And another problem for tables that are not normalized is update, delete, and insert anomalies. You can end up having data inconsistencies. We'll see an example in a second. And faster access to data. If you have a more optimized database, you're going to have faster access. Data redundancy and update anomalies. Relations that contain redundant information will eventually suffer update anomalies. And there are three types. Now look at these two different design of the same table. So on the left side you have two tables that store the same information, staff and branch information. And on the right side you have staff branch table, staff branch relation. It's one table that stores the same information as those two tables on the left side. So these are two different design choices, right? You can have two different tables that stores the same data, or you can have one table that stores all that same data. Now, if the problem here is, first of all, the data is repeated in the staff branch table, because for every employee, you store their branch number and their branch address. Now, this is not good because it causes data redundancy. For example, for both Ann Beach and David Ford, you are storing the address one more time. And then again, for Susan Brand, you also have the address data stored. So first, this wastes storage. Second, if when you add up a lot of data, it slows down queries. And another problem with that is what happens if you update the address in one of them and not the others. So then you have inconsistent data. Let's say for some reason the address got updated. Excuse me. The address is changed in this row, Susan Brand's row, and let's say it became 165 Main Street, Glasgow, and the other two rows here where the address is stored didn't change. So now we have data inconsistency. On the other hand, a deletion of anomaly would be that if you look at the branch 007, there's only one person, Mary Ho, is working at branch 007. Let's say Mary Ho got fired, and let's say this row is deleted from the database. Now you lost the branch number and the branch address. You lost that data. So these are undesired situations, and to prevent these, the database tables needs to be normalized. And on the left side, as you can see, a larger table can be decomposed into smaller tables, and this way there's less redundancy, less anomalies. But how do we decompose? Do we just decompose as we please, or how should it work? First of all, the logically closely related attributes should go into tables that make sense, right? So all staff related information goes in the staff table, branch related information goes to branch table. Okay, that's one thing. And then the next one is we're going to see is decomposition rules. Lossless joint property. So we're going to check for three things. If you're going to decompose relation R into relations R1 and R2, first, the union of attributes of R1 and R2 must be equal to the attributes of R. Now let's see. The union of attributes of staff and branch must be equal to the attributes of staff branch. And if you look at it, staff name, staff number, name, position, salary, branch number, and branch address. So that would be the union, right? So basically you add the branch address here, and you have the same attributes in the staff branch. So this decomposition satisfies the first rule of lossless join. The second rule is intersection of attributes R1 and R2 cannot be empty. So intersection cannot be empty. It means that they have to have something in common. They have to have a common attribute. In this case, branch number is the common attribute, and it's also the foreign key. So it's primary key for the branch number, but it's the foreign key for the staff number, because it's this way with the branch number you can detect which staff works at which branch. Okay, and the last rule for the lossless joint property is the common attribute must be a key, which is also satisfied because branch number is a key. Okay, primary key here, foreign key here. So this is a guideline for decomposing tables. You should not be losing attributes, and you should still satisfy all the dependencies. The other properties for preserving properties. If a relation R is decomposed into relations R1 and R2, all dependencies of R must be part of R1 or part 2, or must be derivable from combination of functional dependencies of R1 and R2. We'll talk about functional dependencies in the next video, and this rule will make some more sense.